Okay, in this video we are going to look into the WYZE webcam, where you can gain access to it over the internet using Wi-Fi, so you can monitor your house or your work location. And there's also WYZE Sense, where you could hook up motion sensor or a contact sensor, so you could hook this up to a door, and every time the door opens or closes you'll get a notification on your cell phone. Now on the back of the camera there's two USB ports. The bottom one is for powering the unit, and the top one is for a radio bridge. Because this sensor here contains a little button battery, so the radio incorporated inside this module cannot support Wi-Fi. It would be too much of a current drain. So there's a little radio transmitter receiver inside this module that runs on the ISM band, and it runs on 906.8 megahertz. And that transmits over to the bridge radio that's inside here, and then from the bridge radio it connects to the Wi-Fi and transmits it over the internet, and you'll get a notification on your cell phone when a door is opened or closed. Okay, I paired my contact sensor to my WYZE camera bridge, and I did that through this little hole on the side of the module, and there's a little tool that comes with it, looks like that, and you just press it into the hole and it pairs it to the WYZE bridge. So now I'll activate it. I'll bring it close till it activates. You can see you get a time stamped. It was closed, and I take it away, and there's an open time stamp. So there it is, sensing the open and close of our little contact sensor. Okay, I have an RF field strength meter powered up on my bench, as you can see here, and it has 5 LEDs indicating RF field strength. And I also have a receiver on that's tuned to 906.8 megahertz. So we could see and listen to the data bursts as we activate and deactivate our contact sensor, and it sends the data over to the bridge radio that's in the WYZE camera. Okay, so this WYZE sensor is basically a magnet proximity sensor. So when the magnet comes close to the sensor, it activates a reed switch inside the sensor, which will give us an open and close indication of, say, a door. Now when that reed switch is activated, it will send a signal by radio, a 900 megahertz ISM band radio signal, to the bridge radio. This is what you see here. Now this bridge radio is connected to the camera itself by a USB port, like that. So now the signal from the sensor goes into the bridge radio, and that information is sent to the Wi-Fi, and that's sent to your Wi-Fi router, then over the internet, and then we get a notification on our cell phone. Okay, so in this video we are going to go a little bit further. We're going to remove the magnet and replace it with a microcontroller, which will be connected up to the sensor. So now we could hook up any type of sensor to the microcontroller. It could sense current or voltage or temperature, humidity, impact. We could have an accelerometer using the I2C and SPI bus. So we have a lot more options. Now when the sensors that we have hooked up to the microcontroller exceed a certain threshold, we can now switch the contact in the sensor, and that will transmit the signal over to our bridge and into our camera over the Wi-Fi and into the internet, so we can get some notifications. So that gives us a lot more options when we have a microcontroller instead of the magnet controlling our sensor. Now to hook up the microcontroller to our sensor, we have to modify our sensor, and if you look at the side of the sensor, there's a little slot for a screwdriver. You can pry off the back cover, and we can have a look at inside the module. You can see it's powered by a little coin battery. We can pop that out, and we can have a look inside. You can see the antenna on the left, and if you look closely at the very bottom, you can see a reed switch. So we take the board out, we remove the reed switch, we connect two wires where the reed switch was, and we bring those two wires out of the enclosure so we could hook it up into a breadboard where we could interface it to a microcontroller. Okay, I have removed the circuit board, and it was held in by one point, this point right here. So we disconnected here, the whole board just comes right out. Now if we look at the back of the board, you can see the heart of the circuit is this IC here. It's a transceiver chip made by Texas Instruments. It's the CC1310. It's their simple link line of transceivers. And on board this transceiver chip, there are two ARM microcontrollers. There's an ARM Cortex M0 for the radio, and an ARM Cortex M3 for the main CPU. And if we look here, we can see our reed switch, and there's the two solder pads. So we just have to unsolder these two pads, take out the reed switch, hook up two wires, so we can interface it to our breadboard. Okay, I have a Nano powered up on my breadboard, which is controlling this relay, and the relay contacts are connected up to my modified WYZE sensor. So when I activate the relay, it will short the contacts and the sensor will activate. So I'll do that. I'll turn on the relay. And I got my notification. And I'll turn off the relay. And there's my notification. So that's the simplest interface, is just using a relay, because it's similar to the reed switch that was actually inside the module itself. Now another way we could do this, another variation, is to use an optocoupler. Okay, in this circuit, I have pin 13 of the Arduino Nano driving the input of my opto-isolator, and the output of the opto-isolator is driving my WYZE sensor, my modified sensor with the two wires. So I'll turn on the opto-isolator. There's my notification, and I'll turn it off, and there's my notification. So in this circuit, the sensor is totally isolated from the microcontroller using an optocoupler. Now when the microcontroller activates the sensor, the notification that we will get back on our cell phone will be contact open and contact closed. Now if we have a temperature sensor connected to a microcontroller, we want a notification to say temperature exceeded. So to do that, we could use the app IFTTT, if this then that, which is supported by the WYZE camera, and we can make our own custom notification to say temperature exceeded. So this is the app here. So if this is the trigger. So when we activate our sensor, that will be the trigger, and then that will be the notification, the custom notification that will say temperature exceeded. Okay, here's our WYZE triggers, and if you look down, we can see contact sensor closed and contact sensor opens. So if we select that, and we'll select our sensor, now we go to that. Now we could select notifications, and we can make a custom notification that will indicate temperature exceeded. Okay, the range of this system would be the range of your Wi-Fi, which would be confined to your house or a building. Now to get long range, we could use a LoRa radio module like this and hook up the serial port to the serial port of our Arduino Nano. Now we could get data from the field, so this could cover a large farm, send data in from the field and then out to the internet for notifications. Okay, so now you know how to hook up a WYZE sensor to a microcontroller. And this is probably the easiest way to send sensor data to the cloud, because there's no network programming involved. It's all taken care of by the WYZE app and the IFTTT app. You just have to concentrate on your sensor and the code that's running your sensor. Now to set up the WYZE camera and the WYZE sensor, it's very easy. Just follow the instructions that come with the camera. It's very easy to set up. Just download the WYZE app and download the IFTTT app. And then modify one of these sensors and see what kind of applications you could come up with a sensor and a microcontroller.